Our next presenter is Richard Corden. This time I was right. Richard works at Perforce.
Yep.
So one of the companies developing static analysis tools and conformance tools. Yeah. And he is also a member of the group of people that have been working on the new MISRA standard. So how many of you use a coding standard? Any coding standard? Okay, good. How many of you have used the old MISRA? Okay, now I'm going to make a question that you are not going to like, Richard. How many of you enjoyed the old MISRA coding guideline? Come on! Well, AutoSAR is slightly better. And from what I saw from the new MISRA is even better. But let's see what Richard tells us. And by the way, we have also in the front line Peter, who will be giving a talk tomorrow about MISRA.
Okay, so I'm not going to go back through introducing myself. I think Daniel's done a good job. I have been on the ISO committee a little bit as well. I don't attend every meeting, but my first meeting was back in 2001. Just a little bit about MISRA. It's overseen by the MISRA consortium, and there's rumors that they are going to start another standard for a different language, Rust, which I'm not going to mention here, of course. So apparently, if you're interested in that, you can maybe contact me, and I can put you in touch with the relevant people. Okay, so now that you've all had lunch, we'll do a little bit of exercise. There's going to be a lot of raising the hands here. That's how I'm going to do this. So I've picked a couple of guidelines. For each of the guidelines, maybe some of the related ones, I'm going to show you the guideline. It's only just the guideline, so there will be other details underneath that you won't have. I'm going to then show you a snippet of code, and the question is going to be is it compliant or are there non-compliances? And if there are non-compliances, how many of them are there? So a non-compliance is basically a violation of one of the rules. So the question is going to be, you keep score yourself. So would you be able to write code that's, according to those rules, compliant? All right. So here's our first rules. Oh, and I should mention that if you're looking to cheat, obviously Peter is going to get all of these right. So you could just copy what Peter does.
You cannot vote, Peter.
Oh no, I want him to vote because I want to see, does he get them, all right? Okay, so functions should not contain unreachable statements and controlling expressions should not be invariant. I'll just give you a few seconds. So there could be more than one non-compliance in the example, okay? So there's two rules are being applied, but there could be more than one non-compliance. Okay, and finally, 4. So unfortunately, Peter's right. So there's basically 2 invariants and 2 unreachables. So the line 16, that I is unreachable because bar is declared to be no return. You have on line 9, you have an unreachable after the break. And then you have the invariants. So you got the false and the if condition. And I was initialized to 10 in the case label 0, so that's going to be invariant as well. As it happens, the rule does not consider the block of the if statement as being unreachable, and this was to try and avoid crosstalk between the invariant conditions and unreachable. So it's only there's a special rule, a special case for basically constants for the unreachable, but in that case, that's not actually a constant expression. Okay. So now we'll go on to the next one. Block scope declarations should not be visually ambiguous, and an explicit type conversion shall not be an expression statement. Okay, in the example. Okay, so there's 4 of them. So we have, in this case, it's quite an obvious function declaration and block scope. That's basically, if it was a class type and it was a declaration, it's the famous, problem with parsing where it looks like an object declaration, default initialized, but it isn't. So that's basically non-compliant there. Line 7, that's an interesting case. So the parentheses around declarator are optional. So that's actually a declaration of an object M1, which has unique lock type and is default initialized. In the case of line 8, it's a cast expression, as is line 10. And even though line 12 is a cast expression, it's not a statement expression. So the lock will be acquired before the function is entered, and then when the function exits, it'll be freed. So that's okay. All right. A name that is present in a dependent base shall not be resolved by unqualified lookup. This one is it should be really easy, this one. Okay, so the code is fully compliant. 1 non-compliance. 2 non-compliances, 3. Okay, so if you said 2, you're correct. So in this case here, because the rule's about lookup, you don't look up into dependent bases. So the fact that there's a type defined on line 4 is irrelevant from the lookup perspective. It's going to find the name in the global namespace. The same thing happens for bar in this case because it's got a dependent argument. It would be an error if it didn't have a dependent argument, but it has a dependent argument. So it's going to be found by two-phase lookup when the struct A is specialized or instantiated. Okay. The same type aliases shall be used in all declarations of the same entity. All right. Okay, so if you said 1, you're correct. So it's only looking at the aliases, and as it happens, F4 is a redeclaration. Is an overload, not a redeclaration. So that was just me being a little bit smart, I suppose. Okay. No conversion from type bool and no conversion to type bool. Peter's now sitting there wondering, what did we say about that? Okay, fully compliant, 1 non-compliance, 2 non-compliances, 3 non-compliances. Okay, so Peter got it right. It's 2. There's a special rule to allow the IFP, basically. It's considered to be, you can implicitly convert from a pointer to bool in a contextually converted to bool context. All right. So this one is going to be interesting for those of you who've used or are using AutoSAR and the previous MISRA C++. Oh, sorry, I should just point out, by the way, type category would be floating point to integral or character to integral. That doesn't apply, like the example I'm showing here has no type category changes, so you can ignore that bit. It's just about the signness. Three or four. So on line 9, you have an unsigned char, which is we would consider it as an arithmetic type, and it's been converted to a signed type. On line 11, again, it's been promoted to a signed type. Line 12 is the controversial one from somebody who's using AutoSAR and previous MISRA, in that would actually have been considered okay in the previous versions. So the previous versions of the standards, they had like an underlying type concept. And the idea was to, if you could work out if you could tell that you knew what you were doing, then it would sort of be more relaxed, I suppose. So where all the types were the same, that was actually okay. The issue when you come to things like return type deduction or declaring variables auto is that it just becomes too difficult to try and reason about what happens, So if I had said auto x equals u8 plus u8, well, what's the underlying type of x? Do I need to keep track of that? Do I need to worry about it? So basically, we've embraced the actual type system of the standard, and that's what's been checked against. So it's the real types that the MISRA C++ 2023 is looking at.
Quick question.
Yep.
This code is absolutely illegal anyway, right? It's only this particular rule has these 3 things because it's just expressions which don't do anything.
So it's whether it was compliant to the rule as I had,
Okay.
yeah.
It's just this one.
But thank you, Dimar. All right. Structure of a switch statement shall be appropriate. MISRA says, I know, yeah, it's great, right? MISRA says appropriate when you then have 2 paragraphs of descriptions or 3 paragraphs of descriptions saying what appropriate means. So I picked this. This is a good one. This is a good one. Okay, so you've got to put yourself into the MISRA mindset, okay? Safety related, explicit, show what you mean, right? So embrace your inner MISRA. So it's fully compliant. So there's no problem with this according to the MISRA rules. There's no funny requirements about where you put the break as long as it is, the last sort of...
What would be an example of a switch statement that is not compliant?
Without the fall through, for example. It is probably the quickest one to describe. No. So the 2 labels together are seen to be obvious. They're obviously a label group. So it's
just to understand that the switch is okay. That is not a no.
So you have to read. You have to read the So I can
The issue with that is that if you, instead of 2 you have 7, you are going to write a lot of useless fall-throughs.
Okay. Snippet 8. All right. Special member functions shall be provided appropriately. Now this one is going to be slightly different, just from. So we've got 2 classes, class A1 and A2. So basically, are they both compliant? Is A1 non-compliant and A2 is compliant? Is A1 the other way around? And then finally, are they both non-compliant? Okay, so Peter, so far I think is 100%. A2 is non-compliant. MISRA C++ has finally come into the world of embracing things like, the rule of 0 and allowing the compiler to do what it knows how to do best. So there's no need to be explicit about all the special members, and to a certain extent, I think from the move from 03 to 11, where new members were added, had you been explicit, you'd have been potentially penalizing future benefits of the language. Okay, and the last one. All class templates, function templates, object templates, member functions of class templates, and static members of class templates shall be instantiated at least once. And here's the code example. All right, so actually, Peter got one wrong. This rule never made it into MISRA C++ 2023. So you can't write modern C++ if you've got a rule which is going to require you to have absolutely everything instantiated. The standard now has definitely embraced, what is in your binary, that's what matters, and you've got to make sure that is correct and safe. But You know, if you've got library code and you've got templates, you know, however they're used, you don't need to go off and instantiate them. So there you go. That was another leaving tricky. So any questions? I'm pretty much at the time, so I don't know if I thought it was 20 minutes, right? Yeah. So. I think.
Yeah, thank you. And regarding the first example, I don't remember, maybe Antosar, but there is a rule that switch should always contain default. And in the first example, it did not have it, and it's not marked as a complaint. Is it? Should it?
I think we have something special about, I think there is something there about enumeration, if it's got enumerations, and I'd have to check it.
Enumerations without an underlying type. If I remember it correctly from the top of my head, there's a special case about using an unscoped enumeration type on the switch that doesn't have an underlying type, so only the enumerators are kind of valid values, and then you might leave out the default if you name all the valid values.
Yeah.
The problem is there's another rule tells you not to use unscoped enumerations without an underlying type.
But
Hi, I have two questions. The first one is the easy one.
Right.
Is there some static analyzers or tools enforcing or checking automatically MISRA?
of course there are.
You are developing one. And my second question is, in your estimation, how beneficial is MISRA in terms of increasing the correctness and safety and security and whatever of the code that abides by it?
So, especially this particular version, I don't think there are. So what I was hoping to get across here really is that the rules that are there, the guidelines that are there, are common. They're well-known guidelines. They might have a focus a little bit more in. There are guidelines that are a little bit more related to safety related. So there's advisory rules about memory allocation, maybe only happening after startup. That sort of a thing, which is very much focused on safety, but I don't think anybody would have any problem with the majority of the rules. I think I can't imagine anybody here really complaining about them. So I think a definite improvement. Thank you.
I'm wondering, is it useful, this MISRA? For example, in the first case, it was the guideline, expressions in the if statement shall not be invariant, but it's not provable for a statement to be invariant in general. So this is a not provable guideline. Or then we had this integer example, and it seems that integer promotion is allowed, which I think is totally strange in C and makes a lot of bugs. But so yeah, it's actually very similar to the question before, but especially in the view of some guidelines are wrong mathematically.
So guidelines are wrong.
The first guideline is not provable. So in general,
There's an awful lot of the nature of what we do quite often. So MISRA actually has a concept of decidability. So all of the rules will come along. So for example, the first rule that talks about unreachable statement has been phrased in a way that it is decidable, because it is purely to do with whether there will be like an edge from, so after, if you take the switch statement example where you had break I++, that is, that's unreachable, okay? The invariant conditions, that rule will be undecidable. It'll be flagged as undecidable, which pretty much means that it's up to a quality of your implementation to decide that it does its best to come up and tell you, we think this is invariant. But there will be false negatives and false positives depending on the where the input is coming from, because obviously you could be reading input from a file. It might not even be in the source code to know that something is invariant. And then you have whether the tool is able to detect it or not.
thank you.
Can you go back to the snippet for the conversion to and conversion from Boolean, implicit conversion? This one. So the last if
Yes,
is not considered as.
because the context is contextually converted.
So what's the nuance between contextual conversion and implicit conversion?
So,
Doesn't it serve the same practical effect?
well, there isn't a change. There isn't a difference from the compiler's perspective. But there was a difference in that if somebody looks, the committee decided at the time that if they look at line 5, they're happy that will be testing that the pointer is not null. If they were looking at line 4, you got a question: is the star, is the dereference missing? So it's purely based on that. It could have gone the other way.
I mean, because I had clang tidy flag in that last case. Oh, you're implicitly converting to Boolean. It's a pointer, so I have to explicitly compare against null PTR.
And I believe in AutoSAR and I believe in MISRA C++ 2008, you would have to. Yeah.
Clang tidy has many rules, and you need to make a choice which rules you want to enable or disable.
Yeah, thank you for the talk again. And in the previous joke, we used MISRA and AutoSAR guidelines, and we have a paid static analyzer to check them. And I found it quite useful and nice. But I also would like to use some static analyzer for my private projects. Do you know any open source software, maybe not for the most modern, but the previous MISRA, AutoSAR guidelines or something?
So I personally don't know anything to recommend to you, but I know, in general, compilers are getting much better at detecting things. So I imagine that over time, the things that maybe are more obvious, if they're not already, if Clang isn't already detecting ++I after a break statement, but okay.
It would be nice if there's someday.
Okay, thank you.
All right.
I think
Thank you very much,
to
Daniel.
keep on time. Thank you very much.